we start with OSHA. The students have to have their OSHA certification. We do a 10-hour OSHA class. After that, once they get that certification, then we move into our welding, or my safety, and then we move into welding. Start out with basically a flat weld, and then go to a 2F, which is a T-weld, and then move up into different positions from there, and going all the way up to either a 6G, which is a weld that's a 45 degree on pipe all the way around, or even TIG welding. But the certifications that they'll absolutely get in welding is a OSHA 10-hour certification, which you can use in industry, and it's the same industry certification that you'd have to get if you went to work at Home Depot or Lowe's or even an industrial shop, as well as at least a tack welder qualification for AWS, the American Welding Society, for welding. We had just started our cutting activities, plasma cutting and oxy-fuels cutting for a acetylene and oxygen cutting torch. So in any industrial shop, you're going to have a cutting torch rig, and they absolutely have to know how to use that, set their pressures. And actually, that is another certification that we just started this year. So those students would come out with 3, like those previous 2 that I spoke about, as well as the cutting torch certification. And Texas is moving towards that. Many other states, you have to be certified to even be able to get bottled. So what do they need to do to get certified? For a 2F weld, the weld has to be 5/16 from toe to toe, which is from one side of from the top of the weld to the bottom of the weld, has to measure 5/16. It's got to be 8 inches long with a tie-in in the middle. Can't have more than 1/32 undercut. Can have no porosity in it, and it's with a 7018 welding rod, or welding electrode, if we say it properly. On a tack welder qualification, the parameters are the same but with a 7018, but it's a 2-inch weld that is a 1/4 inch measurement, but still have no porosity and in less than 1/32 of undercut. When we move into our Gs, our 1G, 2G, 3G, 4G, that kind of thing, that's with 2 plates that are beveled with a 30-degree bevel, and then we start using multiple different electrodes. We'll start out with a 6010 hot pass, which is when we weld those 2 pieces together. Then we'll go into a 7018 fill pass with a 7018 cover. And once those welds are done, we cut the ends of them off. We micro etch those with some acid, much like your battery acid, and we can see inside that weld. We can see how much penetration that student got with that weld bead. We can see if there's any other porosity that we wouldn't be able to see visually on that, and then we actually break it. And if that weld fails, well, ideally we want it to, so we can see in it, we want it to fail evenly. If it breaks and doesn't pull any base metal off with it, then ultimately the weld didn't do what it needed to do, because it didn't penetrate that base metal. If it does gouge out and take base metal with it, that's okay. But if it breaks evenly, that's even better. Ideally, with the electrodes, they have more holding power than the base metal per square inch. 7018 has 70,000 pounds of tensile strength per square inch. A 6010 has 60,000 pounds of tensile strength per square inch. So you can understand that's quite a bit. It shouldn't, the base metal should fail before the weld. We actually go in, we come into the shop, and every student in the class uses every piece of equipment, with either me holding their hand or looking right at them while they're doing it. So that way there can be no question of, did that student learn how to use that? Did they learn how to use it properly? And do they know how?